Hello everyone, welcome to the mathematics class by a.k.mishra education for better tomorrow guys. So today I am going to discuss about the exercise 7.1 into part 2 guys, and this chapter belongs to the you can say that uh, what guys, class 8, and the chapter name is cube and cube root, and this is the most important for the cbse 2021 student, right? So, and this is presented by me Ashish sir, and you can follow me on Unacademy Plus platform also guys, and you can follow me on all the social media. Link is given under the description box, right? And on this channel I am teaching as a math faculty and science faculty from 8 to 12th guys, right? As well as I am taking the classes of the NTSE, IIT JEE mains and advanced. So if you are new on this channel, so please subscribe this channel and don't forget to press the bell icon and set at all guys, because you will get all the notification on time, right? So guys, without wasting your time, I am going to start the session guys. I would like to inform you that I have already discussed the about the cube numbers and cube relation with the cube number and unit digit in the cube number in the part 1. So if you want to see the part 1, so go and see in the playlist guys. Playlist is available on my channel. So after uh, being and after reaching on the playlist, you can watch the video guys, okay? So guys, today I will discuss about the some interesting patterns, right? So some interesting patterns. So and this is the most important for the better understanding of the cube number guys. I would like to inform you that. So guys, first interesting pattern, adding consecutive odd number, okay? So we know that first odd number is the 1. 1 is equal to 1, we can write here, and it is the cube number of 1 guys, because cube of 1 is equal to, we can write 1. Now I am going to take next two consecutive odd numbers. So after 1, we can say that 3 and 5 the next two consecutive odd number, and after adding we will get the result, what guys, 8. And 8 is equal to, we can write here, what we can write here, 2 raised to the power 3. Okay, everything clear? Similarly, now after taking the two consecutive odd number, after adding the two consecutive odd number, now I am going to take the next three consecutive odd number, and we have to find out, we have to sum, okay? So after adding, so we will get 7. We can say that the next consecutive three odd number is after the 5, we can say that 7, 9 and 11, and after adding we will get 27, okay? And 27 equal to, we can write here, 3 raised to the power 3. Similarly, now for the next number cube, we can find out, the after adding the next four odd number, we will get the result of the cube of the 4 number, right? So, and for the next process, for the obtaining the next cube, so we have to add the next next 5 odd number guys, next 5 consecutive odd number. So we can say that next 5 consecutive odd number is what guys? So after 19, we can say that 21, 23, 25, 27 and 29, and after adding we can write here 125, and we can write here it is equal to the 5 cube. So you can say that when we take the one consecutive number, so we will uh, we will get the result of the cube of the 1. When we when we take, what guys, when we take the two consecutive odd number, and after finding the sum of the two consecutive odd number, we will get the cube of the 2, right? So it is equal to the number of the odd number guys. Now after this, we have to find out the next 3 consecutive odd number, and we have to find the sum, and after adding we will get the result 27, and we can write here 27 is equal to 3 raised to the power 3. So we can see from the above pattern we need to find out the n to the power 3, n to the power 3. Okay, so you can better understand, because n to the power 3, we can say that from the above pattern, we need to find out n to the power 3, and we have to take the n consecutive what guys, consecutive odd number will be needed, such that the sum is equal to the n raised to the power 3. Okay, so here is n raised to the power 3 guys. Okay, so this pattern hold for all natural number. Just like you have to find out the 6 cube, so after 29 you have to add the 6 consecutive odd number guys. Just like you can write here 31 plus 33 plus 35 plus 37 plus 39 and plus 41, and after adding you will get the result 216, and you can say that it is equal to the 6 raised to the power 3. So you can say that if you have to find out, if we need to find the n raised to the power 3, because when we take the what, when we take the one odd number, and after adding we will get the one, and we will get the cube of the one guys, right? And when we take the next two consecutive odd number, and we have to find out the sum, so after the one next two consecutive number is 3 and 5, and after adding 3 and 5 we will get the 8, and 8 is the cube of the 2. So we can say that, what we can say that it is equal to the number of odd, when we take what guys, how many number of odd consecutive number we have to take, right? We take, so that is equal to the n cube. Okay, so you can say that we can see from the above pattern, if we need to find the n raised to the power 3, n consecutive odd number will be needed, such that their sum is equal to the n raised to the power 3, and this pattern true for all natural number. Okay, right? Okay, and next you have to find out the 7 raised to the power 3. So after taking 6 up to the 41, and we have to take what guys, after 41 we have to take the 7 next consecutive odd number, and after adding we will get the what guys, we will get the cube of the 7. Okay, so we can write here, what we can write here guys, this is simply we can write here, what we can write here, this is the we can write here with 1 minute. Yes, so we can write here guys, what we can write here, 41 plus 43 plus 45 plus 45 plus 47 plus 49 plus 49 plus 51 plus 53. So it will be the, it is equal to how many number of the odd numbers we are taking, so 7. So after and after adding you will get what guys, we will get the 343, and it is equal to the 7 raised to the power 3. So this number, this number and this number are equal to each other, so we can say that how many numbers, so we need to find out the, we need to find the 7q. So we have to take the what guys, we have to take the 7 consecutive odd number will be needed, such that there's the sum of the 7 consecutive odd number is equal to the 7 raised to the power 3. So you can say that guys. Okay, definitely you are getting very well, so please write yes in the chat box and share it to everyone guys, right? So now and next pattern I am going to discuss about the guys prime factorization method to the find a cube. Okay, this is the very simple. So before understanding the prime factorization, you must know about the what is the prime number. Okay, so prime number, the number which is divisible by only two different numbers, just like you can say only two factors. Okay, so guys you can say that what, just like 2, 2 is divisible by 1 and 2, so it has only two factors, so we can say that it is a prime number. Another is 3, so it is also divisible by 1 and 3, so we can consider it as a prime number. And but 5 is divisible by 1 2 sorry 4. So 4 is divisible by 1 2 and 4. So it is not divisible by only two different number, so we can't consider it is a prime number, it is a composite number because it is divisible by more than two numbers. Okay, so it has more than two factors, so that's why we can say that it is a composite number, but 2 and 3 is the prime number. Okay, okay guys, are you getting my points what I am saying? And this is the composite number. So you must know about the prime number before understanding the prime factorization of a prime factorization to find a cube. Okay, this is the very simple. So guys, in the prime factorization of the any number, each prime factor appear the three times, then the number is a perfect cube. This is the very simple, right? So just like this, you can write here, consider the number 216 by the prime factorization. We can write here, how we can write here the prime factor, how you can write the prime factorization after dividing. First of all, we will uh, we will divide by the 2 because 2 is the smallest prime number. So first of all, we will divide what by 2 guys. So we can write here, what we can write here, 2 ones are 2, 108 it will be. And after once again we can divide the this 54. Once again we can divide the 54. So 2 2 27s are 54, and now we can't divide by 2. Next I am going to divide by the 3. So it is divisible by 3, so we can write here 3 9s are 27 and 3 3s are 9. So we can write here the 216 is equal to 2 into 2 into 2 and 3 into 3 into 3. So we can write here, and we know that one concept, guys, this is the most important thing for you. Just like you can write here, any terms is multiple in any n number of time. Okay, so and the base is the same. So and the sign is present between the given term is what guys, multiplication. So after multiplying, we can write here, we can add the power of the given term, because you have to check the two things. First, base is the same and multiplication is present between them. Okay, between the terms, so you can add the all the terms. Okay, so 2 into 2 into 2, so we can write here 2 raised to the power 3, because here it is not nothing is available. So you can write here, you can consider it is equal to the 1. Here 0 is not present because the any number raised to the power 0 is equal to 1. So we can't take the 0 at the uh, power place guys. So we can write here the 2 raised to the power 1 and 2 raised to the power 1 into the 2 raised to the power 1, and after adding, because the multiplication is present, so we can add the power of the given term guys, and base is also same. So we can write here 2 into 2 into 2 is equal to, we can write here 2 raised to the power 3, and 3 into 3 into 3, so we can write here the 3 raised to the power 3. So the both the prime factor prime factor appears the three times, so we can say that the 216 is a perfect cube, right? Okay, everything clear? So similarly, now I am going to take the another example, 500. So 500 you can also factorize guys, and after factorizing you will get what guys, you can write here, you can divide 2 220 250, and we can write here the 125, and we can write here 525 and 55. So we can write here that 500 is equal to 2 into 2 into 5 into 5. So we can write here 2 raised to the power 2 and 5 raised to the power 3. But here the 5 factor 5 appears 3 times, but factor 2 does not appear the 3 times. So we can say that what guys, we can say that what, 500 is not a perfect cube. Why? Because as we know that in the prime factorization of any number, if its prime factor appears the 3 times, then the number is a perfect cube guys, right? Okay, everything clear, right? Now I am going to discuss about the very important number, guys. This is the Hardy Ramanujan number. Okay, so Hardy Ramanujan number is a that number. This is that number we can express. The number we can express, and we can write in the two sum of the two type of the cube. Okay, so you can but better understand through the example, guys. So we can take the 1729, right? 1729 is a smallest Hardy Ramanujan number. A number can be expressed. What is the Hardy Ramanujan number? So the number which can be expressed as the sum of the two cube in the different ways is known as the Hardy Ramanujan number. So 1729 we can write here the 1728 plus 1, and we can also write the 1000 plus 729, and 1728 is the cube of the 12 square, and 1 is the 1 cube. So this is the first way to express the 1729. And another way, we can write here 1000 plus 729, and we can write here the 10 to raised to the power 3 plus 9 raised to the power 3. So we can say that it is the smallest. 1729 is the smallest Hardy Ramanujan number. And what is the Hardy Ramanujan number? A number which can be expressed as a sum of the two cube in the different ways is known as a Hardy Ramanujan number. Right, guys? Everything clear? Okay. So, guys, and there are the infinitely many such number. You can take the another example also, guys. Another few examples is given here. 1401, because we can express in the 2 and 16, and another 9 and 15. Okay, so you can write it as, and 13,832 you can express into the sum of the 18 cube, right? So you can take the another example also. 4104 you can express 2 raised to the power 3 plus 16 raised to the power 3, and another example. And you can also express 1404 is equal to 9 raised to the power 3 plus 15 raised to the power 3. You can express. So you can say there are so many example exist, but 1729 is the smallest Hardy Ramanujan number. Another example you can write here the 1383, and we can write here what, guys? 18 raised to the power 3 plus 20 raised to the power 3. Okay, so after adding you will get the 13,832. And similarly you can write here the 13,832 is equal to 2 raised to the power 3 plus 24 raised to the power 3, and after adding you will get the 13,832. So there are so many such number you can understand. Okay, right, guys? So now I am going to discuss the next concept, guys. So there are so many questions is asked in the examination, guys. You have to find out the uh, just like you can take the example, and the question is on the screen, guys. Is 392 is a perfect cube? And if not, find the smallest natural number by which the 392 must be multiplied so the product is a perfect cube, guys. Right? So this is the very important. So first of all, you have to check the perfect cube. How you can check it is a perfect cube or not? Because the each factor appears the 3 times. Okay, after finding the prime factorization, after doing the prime factorization, each factors appears the 3 times. Okay, so guys, and so first of all, we have to check 392 is a perfect cube or not. So first of all, I am going to find the prime factorization, because and it is a sum. It is a what, guys? Even number. So we can divide by 2. So 196, and after dividing 2, we can once again divide by the 2, and we can write here 2 9s are 18 and 2 8s are 16. We can once again divide by the 2, and we can write here what we can write here, guys. We can write here it will be 2 4s are 8 and 2 9s are 18. Okay, and now it is not divisible by the 3, it is not divisible by 5, then we can divide by the 7. So it is divisible by 49 is divisible by 7, so we can write here the 7 into 7. So what we can write here, so we can write here 392 is equal to, we can write here 2 into 2 into 2 and 7 into 7, right? So guys, here how many factor is available? Here is two prime factor is available. First one is 2 and another is the 7, guys. This is the very simple, okay? But 2 appears in the 3 times, right? But 7 does not appear 3 times, guys. So and we can say that what, guys? No, 392, what we can write here, 392 is not a perfect cube, okay? Is not a perfect cube, is not a perfect cube, okay? Everything clear, right? And another question is given, if not, find the smallest number, smallest natural number by which 392 must be multiplied so the product is a perfect cube. So how you can multiply? It will be 7 raised to the power 3, then we can consider it as a, then after multiplying the 7, how we can convert 7 3 times? By multiplying by 7. So after multiplying the 7, we can say that it will become the perfect cube, guys. So we can say that, what we can say that 7 is the smallest number, 7 is the smallest number by which 392 must be multiplied, must be multiplied so that so that the product is perfect cubes, perfect cube. Everything clear? Okay, right, guys? Are you getting my points? Okay. Another question is also given, uh, is 553,240 a perfect cube? So similarly you have to check, and if not, then by which smallest number and should 53,240 be divided so that the quotient is a perfect cube? This is the most important and very simple question, guys. And this question is also available here, so you can say that how, by which number, by which number the 392 must be divided so that the product is a perfect cube, guys, right? So this is the very simple. You can say that because due to the 27 it is not considered, due to the 27 available in the prime factorizations. So we can say that 392 is not a perfect cube. So after removing and after adding the 17 and after removing the 27, it will be what, guys? It will be the perfect cube. But in the questions, you have to find out the multiplications, okay? So 392 must be multiplied so that the product is a perfect cube, so you must have to multiply, right? But in the question division is available, means the 392 must be divided so that the product is a perfect cube. So you have to divide the rest remaining unpaired, and the number prime factor is does not come the 3 times, appears the 3 times. So you have to divide the all the that the factors, okay? So you can better understand through the this example, guys. So we are having what, guys? We are having 53,240. So we have to find out the prime factorization. So we can write here 53,250. So we can write here 2 2s are 4 and 2 6s are 12 and 2 6s are 12 and 20. Now we can write here 2 13s are and we can write here 2 13 jar 2 3 jar 6 10. Once again we can write here 2 2 what we can write here guys, 2 6 jar 12, and it will be 2 6 jar 12, and it will be 2 5 jar 10 and 2 5 jar 10. Once again what we can write here, 6 6 12 and 10 22, and now we can divide by the 5. So by the 5 we can write here 5 ones are 5, and 5 3 are 15, 15, and it will be the 15, and it will be the 1. Okay, right guys. And now what we can write here, we can divide by the 11. 11 ones are 11, and 11 twos are 22. Okay, and 11 ones are 11, and we can write here 11 ones are 11, and 11 ones are 11. Okay, so we can write here, what we can write here, the prime factorization of the 53,240 equal to, we can write here 2 into 2 into 2, 2 into 2 into 2, 5 into 11 into 11 into 11. So by observing by observing the prime factorization of 53,240, you can say that due to the 5, it is not considered a perfect cube. So after dividing the 5, we can say that it it must be the perfect cubes guys. So we can say that, so first of all we have to check. So we can say that it is no it is not a perfect cube. Why? Because because 5 does not appear 3 time 3 times in prime factorization, right? Factorization. So that's why we can consider the it is a perfect cubes. And how we can and by the question, another question is, if not, then by which the smallest natural number should the 53,240 be divided so that the quotient is a perfect cube. So this is a very simple guys. So you can say that 53,240 must be divided by the 5, because due to the 5 it is not considered prime factor, right? It is not considered it as a perfect cubes. So we can say that after dividing by the 5, we can say that, so we must divide by the 5, we should divide by the 5, you can write here. Okay, okay guys, so we can write here, we should divide by 5 in 53,240, so that so that quotient quotient is a perfect cube. Okay, right guys, everything clear? So it will be the perfect cube. So I hope everything clear guys. So it is these all are the concept of what guys, these all are the concept of, you can say that the concept of exercise 7.1. And by and after understanding and after watching this session, you are able to solve the all the question of exercise 7.1. So guys, next is in the next session I will discuss the all question of exercise 7.1 guys. So see you in the next class. If you are new on this channel, I hope, if you um, if you are new on this channel, so please subscribe this channel and don't forget to press the bell icon and set at all, because you will get the all the notification all the time. And I hope you are getting very well on this channel guys. So bye bye, take care, best of luck, thank you guys.